Okay, we're here again. We're on 1.6b this time with Logarithm and Blues. But don't worry, I'm not going to sing to you. Logarithms are probably something you've just been introduced to, so the goal would be to help you understand them and how to use them. They can be a bit tricky. Some people get confused with them. The easiest way I've found to remember is by knowing that exponentials and logarithms are inverses. Okay, I'll show you a couple examples to illustrate that. Here's algebraically.
Alex Studebaker, if you are on the grounds at Grand Valley High School, please come to Mr. Greger's room.
B to the y equals x if y equals log base b x. Okay, this is subscript, superscript. Okay, so you can see how those are related. And it does go both ways, so if we wanted to, we could write it like that, if and only if. Okay. At the same token, if I'm going to graph y equals 2 to the x, it would look something like that. No, I'm good. Now if we graph y equals log base 2 to the x, we're going to end up with a reflection over the line y equals x, which indicates that they are in fact inverses. So just be aware that those are inverses algebraically, and well, inverses, but we can show it algebraically and we can show it graphically. Okay, this is going to become really handy when we're solving equations. So let's look at something like, I'm just going to expand upon this. Log base 2 of 8 equals 3, because 2 to the third power is 8. As you can see the relationship. Basically what we're asking here is how many 2's do we multiply to get 8? That's the question. So we go 2 times 2 times 2 is 8. So that means there are 3. This is the answer to the log. Okay. The natural log's pretty important. Okay. So it's just a really specific case of logarithms. And so if I have it's just a log base e. Okay, we note it ln x. Okay, these are interchangeable. use this one. Okay, this is the one we write in the math books. ln x means a logarithm with base e. Okay, so it would be inverse to that, which we talked about what e is. We'll get a lot more specific. Okay, the domain of all logs is a set of x such that x is greater than 0. Cannot count 0 because you can see that this never hits that vertical axis there. The range, set of y values such that y is a real number. Okay, you can see that we go down all the way and we can go up all the way. So domain and range of logs. All right. Let's give me a sheet for this. Don't be scared. Properties. Just like exponents, we have to have properties of logs so we can solve equations. Probably, you can relate these to the exponent properties, like the log of 1. Log any base of 1 is 0, right? Because we know that anything 0 powers 1, right? That's the inverse exponentially, so those go back and forth. Log base b to the b is 1 because b to the 1 is b. Okay, so we can relate these to the logs. Exponent rules. What else do we have? Log base b x times y equals log b x plus log b y. Just like the exponent one. Multiplication means add. Okay, what do you think divide is? Yep, subtract. Minus. I don't know why I underlined that. You don't have to worry about it. Okay. Reciprocals. Log, let me just write log b of 1 over x is the same as negative log b dx. And powers, log b x to the n equals, this one's kind of funny, is bringing the power down in front is kind of counterintuitive, but it's a beautiful thing, trust me. Okay, so we can manipulate logs just like this. I'll just show you a quick example of this one. Bring the power down. Okay, so that's simplifying it using that property. One of the more important ones, you'll hear it referred to as change of base. On your calculator, all we have is natural log, which is base e, and base 10. We can't do like base 8. Okay, so if we have something like base 8, we have to change it into base 10 or base e. So if we put 10 in for a, because there's no a here, we can just put whatever we want. I would put 10, and then the x here and the b here, you got her covered. You can also do it with natural logs. Either one works. Doesn't matter. This is an or. I'll give you the same answer. Okay? Let's do some evaluate logs. Let's try logs base 6, 9 plus log base 6, 4. I think I see. Since this is plus, we can actually put those together and multiply. And then this I can tell you is 2, because 6 squared. So if you want to rewrite it, so at this point I know the answer, but if you need to keep going, now I can bring this out front. We know this is 1. Okay, couple ways to go about it. You can bring that out front. This is 1. Okay. Couple ways to go about it if you want. Okay. All right. We're going to do this we know as negative 1/2 as an exponent. So natural log of e to the negative 1/2. Okay. I'm going to bring it out front. We know that's 1 because it's natural log of e, so we get negative 1/2. Let's do a little bit more of a complicated one. Okay. This right here is 3. This one I believe is going to be 1/2. Because that's an exponent to the 1/2. Log base b is 1, so all you're left with is the 1/2. So 10 times 3 is 30 minus 2, so we get 28. And we're good to go. Alrighty. Let's do some solving. Solving equations. Again, I can't ever show you all the examples you need to want to see for this, so you're just going to have to kind of deal with it and be a thinker. Okay. The example in the book has a bacteria population. As size P of t equals 1000 E 0.35 t. So we start at 1000. It's growing at 35% per hour. That's pretty good. When will the population reach 5,000? Okay. We need to solve this equation. All right. Our first step, so we get 5 equals e to the 0.35 t. This is where logs become really handy. We're going to smoke a ln on both sides here. So we have the natural log of 5 equals 0.35 t, because these two get rid of each other. They're inverses. Calculator. I'm trying to get my calculator. Pretty handy Android app. I'm going to say, what's the natural log? 5. 1.609. Try to go to at least 3 spots every time. And then we divide by 0.35 and we get 4.598. So now this is an AP language, 3 decimal spots.
Okay, you have to do that. That's what they expect the answers in. And they're also going to ask you to explain and justify. So at approximately 4.6 hours, the bacteria population will be 5,000 bacteria. Okay, get used to doing that. Okay, that'll be all for the day. I'm going to put the homework on here again, and 1.6a, 1.6b. Okay, so that's all due 2 days from tonight. Tonight's the 2nd. Okay, so if you're in 2014, it's due on Thursday morning. Toodles.